Go ahead and take a look at lesson 8 of chapter 5, which is going to be the last lesson that we have in this chapter. Our focus today is going to be on factoring linear expressions, okay? And so the overall objective is going to be to use properties of mathematics to factor linear expressions. The big property that we're going to be focusing on is going to be the distributive property, okay? One of the things to take note of on page 415 in your book is your vocabulary words. You are going to see over underneath your vocab that you have 3 vocabulary words that you are going to be needing to fill in on your vocab web. First one is monomial, second one is factor, and the third one is factored form. So please make sure after you listen to the video here that you do take a moment to fill in those words on your vocab map. Okay, we're going to start off on page 416 today, getting into the factoring. My hope is that after you have completed the inquiry lab that was prior to this lesson, you'll have a pretty good understanding of factoring and what that actually means, okay? When you think about factoring, basically we're going to be thinking about what you guys, when you were in elementary school, when you were finding your greatest common factor or even constructing your factor trees, it's kind of similar to what we're going to be doing here, okay? Our goal, like we said before, is being able to find the greatest common factor of monomials. One of the things to remember that you're going to be writing on your vocab web is what a monomial is. This is probably a new word, okay? You may even need to say it to yourself so you know how to say it correctly, but we call it a monomial, and that can be a number, it could be a variable, or it could be the product. Remember, product means multiplication, so it could be the product of a number and one or more variables. So examples that you could have, remember it could be a number, so you could just have the number 25 by itself. You could have the number 10, the number 15, the number 20, those would all be examples of monomials. You could have a variable by itself, so maybe you have x, maybe you have y, maybe you have z, maybe you have a, maybe you have b. Or it could be a product of them. So I've taken a number and a variable and I'm multiplying them. So 40x, or maybe you have 21y, or 52z, 3a, okay? Those are examples. You can also have more than one variable. So one of the things that you may want to consider in terms of an example is you could actually have 8b, c, okay? You have a number, you've got one or more variables, and I'm multiplying them, I'm getting the product. So there could be another example that you would see. Not monomials, okay, or examples that are not monomials would include x plus 4. The reason why this is not a monomial is because you're adding. You do have a variable and you do have a number, but you're adding them, so it's not a monomial. 40x plus 120, again, if I treated these as 2 separate terms, the 40x, that would be a monomial. Or 120 by itself would be a monomial. But because we're adding them together, it's no longer a monomial. Okay, when we're factoring it, okay, what that means is we're going to write it as a product of its factors. Okay, so what am I multiplying? So what times what times what times what gives me my overall answer, okay? Monomials can be factored using your same method you would use to factor a number. Again, we're focusing on our greatest common factor, okay? And so one of the things that your book does is they actually write out what your factors are for each of them. Some of you are going to be comfortable enough and familiar enough with your numbers where you may not need to write out your factors for them. When you're working with larger numbers, you may have to write out what your factors are to figure out what your greatest common factor is going to be. And that's okay. If you need to write them out, that's okay. There's nothing wrong with that. When I think about 4x, okay, when I factor it or think about a factor tree, okay, technically I'm just going to pull away the 4 here. I know 2 times 2 is 4. Both of my 2's are prime numbers, so that's where the 2 comes into play. Now, because we're also multiplying it by x, I technically need to have x involved, and so that's where that comes from. Same thing with 12x, okay? If I'm thinking about 12 and x, basically I'm going to break it down into, let's do 3 times 4, and then times x over here. 3 is already a prime number. 4 can be broken down into 2 times 2, and then I have my x. So I have 2 times 2 times 3 times x. When you factor them, you're looking at what is common. So I have a 2 in both, I have another 2 in both, and I have an x in both. So technically what you're going to do then is you're going to take one of them and just multiply your numbers. So 2 times 2 would be 4, 4 times x is x, or 4x. So your greatest common factor of this is going to be 4x. Another way to think about it is if you treat these as separate terms. So if you just think about 4 and 12 and ask yourself, what's the greatest common factor of 4 and 12, or what's the highest number that will go into both of them? I know that 4 is, and then because I have an x on both of them, I can pull that x out as well. Okay. Example 2, kind of the same idea here. Again, they've written out the factors for 18a and 20ab. One of the things, if I don't write these out, one of the things I might think to myself is what's the greatest common factor, the largest number that will go into both 18 and 20. Okay, I know that I can think about the factors of 18, so 1, 2, 3, 6, 9, 18. Out of all of those, which would be the greatest common one that also goes into 20? I know that would be 2. The other thing I'm looking at is I have an A here and an A here, so I can pull that A out. I can't pull the B out because I don't have a B over here. Okay, so when I think about the greatest common factor, again, 2 is my highest factor that goes into both 18 and 20, and I have an A on both of them, so I can pull out the A. So the greatest common factor of that would be 2A. Here's another example, 12 CD and 36 CD. Again, just think about your coefficients, 12 and 36. What's the greatest common factor of 12 and 36? I know 12 goes into 36, so I can pull the 12 out. Then I notice I have a C here and a C there, so I can pull the C out. I have a D here and a D there, so we can pull the D out as well. So again, we said 12 was the greatest common factor, okay? And a C is in both and a D is in both, so we can pull both of those out. So the greatest common factor would be 12 CD. Let's take a look at a couple examples on the bottom of 416. We'll go ahead and do these together because I know sometimes this can be tricky at the beginning. When we're thinking about 12 and 28C, again, I'm thinking about the largest common number that will go into both of them. I can think about my factors for 28, for example, so I know I'd have 1, 2, 4, 7, 14, and 28. Out of those, what goes into 12? What's the highest one that will go into 12? It'd be 2. So I'm going to pull out the 2. No, I'm sorry. It would be 4. That's my fault. It should be 4. Okay. Now I don't have a C here and I don't have a C here. So my greatest common factor for that is just going to be 4. Looking at letter B, okay, what's going to be your greatest common factor for 25 and 15? Work with your numbers first of all. My greatest common factor, the largest number that will go into both of them would be 5. I have an X in the first term and an X in the second one, so I can pull out the X. The Y I don't have in the first term, so I can't pull it out. So your greatest common factor there would be 5X. Looking at the last one, you have 42 and 14. Be careful on this one. Try to see, 14 is my smallest number here. Does 14 go into 42? So one of the things I'm thinking of, well, 14 times 3 does give me 42. So technically my greatest common factor is going to be 14. I have an M in both, so I'm going to pull that out. I have an N in both, so I'm going to pull that out. Okay, so your greatest common factor for letter C would be 14MN. Okay, next piece that we're going to look at is we're going to expand on this a little bit more. So we're going to be looking at situations that we kind of worked with yesterday in terms of, or actually prior to this lesson with your inquiry lab. We're talking about factored form and what that is. Okay, when it's in factored form, it's going to be expressed as the product of its factors. So one example they give you here is 8x plus 4y. So you're going to notice on these there's an operation within. Okay, I'm again asking myself what's the greatest common factor, the highest number that will go into both 8 and 4. I know that 4 goes into both of them, so I'm pulling the 4 out. Okay, you can see they pulled the 4 out. 4 times what number is 8? Well, 4 times 2, and then I have to have the x in there, so 2x. And then again, I pulled 4 out, so I'm thinking 4 times what number would give me 4? Well, 4 times 1, and then my y is there. Please go back and check it after you factor these. When I take a look at this right here, I should be thinking distributive property. 4 times 2x would be the same as 8x, and 4 times y would be the same as 4y, so I know that I did it correctly. Always go back and double check them after you factor them to make sure that you didn't make a mistake. Okay, 3x plus 9 is the one we're looking at here. Again, I'm just looking at the whole number portion of it, 3 and 9. What would be your greatest common factor for 3 and 9? I know 3 would be, so I'm going to pull the 3 out. Now I'm asking myself 3 times what number would give me 3x. Well, technically that would be 3 times 1x, or 3 times x, plus 3 times what number gives me 9? Well, 3 times 3. Okay, so now I can check it. 3 times x is 3x, plus 3 times 3 would be 9. So it matches up. Okay, they give you the tile method, the model method there that you can kind of take a look at to make sure that it's correct. They also show you the greatest common factor method. Okay, when I take a look at number 5, okay, occasionally sometimes you may run across problems that cannot be factored. Okay, for example, if I look at 12x plus 7y, there's not a common factor other than 1 that will go into both 12 and 7. Okay, the other thing is I have a variable x here and a variable y there. I don't have a common variable in both of them, so I can't pull out a variable. So therefore, because my greatest common factor is basically 1, these will not be able to be factored. So if you run across or come across problems like this on a test or an assignment somewhere, what you would do is you would just put down can't be factored or cannot be factored. Okay. Let's go ahead and take a look at the 3 on the bottom. What I would like you to do is go ahead and pause your video and complete these 3 problems, and then when you're finished, come back and I'll show you if you have your correct answers. All right, hopefully you've had some time to go ahead and complete these 3 got it problems. Let's go ahead and take a look to see if you agree with my answers. As I take a look at letter D, I've got 4x minus 28. I was thinking the number 4 here. I know 4 will go into 28, so that's going to be my greatest common factor. So I pulled the 4 out. Then I asked myself, okay, 4 times what would give me 4x? Well, 4 times x would be 4x. I'm subtracting, so I put a minus. 4 times what number gives you 28? Well, 4 times 7. And again, I can check it. 4 times x is 4x minus 4 times 7 is 28. So that would be correct. Taking a look at letter E, you have the numbers 3 and 33. So starting with my smallest one is 3. Does 3 go into 33? It does. So that's going to be the greatest common factor. So I pulled the 3 out. 3 times what number gives me 3x? So 3 times x plus 3 times what would give me 33y? Well, 3 times 11 is 33, but I also have to incorporate the y in there. So I'm going to check it. 3 times x is 3x plus 3 times 11, y is 33y. So I know that works. Taking a look at the last one, we have 4x plus 35. I'm thinking 4 here. 4 will not go into 35. Then I can think of another factor that goes into 4, and that would be 2. 2 will not go into 35 because it's an odd number and 2 is even. So therefore, your greatest common factor would be 1, so therefore we cannot factor that. And again, we can't do that because there's only an x in the first one and not in the second one. If your variable was common in both, then you would pull out the variable. Okay? Hopefully you were able to get the same answers as I was on that. The last problem that we're going to look at real briefly here is going to be on the top of 418. Again, just kind of talking about dimensions. It says a drawing of the garden at the right has a total area of 15x plus 18 square feet. Find possible dimensions of the garden. So basically what we have to remember here is we're talking about area, so we're going to be factoring this. Okay, so we're thinking 15x and 18. What would be your greatest common factor that would go into both 15 and 18 first of all? I'm thinking about my factors of 15, so like 1, 3, 5, and 15. Out of those, which one would be the biggest that would go into 18? Well, it would happen to be 3. Okay, so we would pull out a 3. There's only an x in the first one, so I can't pull out an x either. So when I think about it, I'm pulling out the 3. Okay, 3 times what would give me 15x? Well, that's going to be 5x. Plus 3 times what is 18? Well, that would be 6. So when you're factoring that, you've got 3 times 5x plus 6. Okay. At this time, what I would like you to do is go ahead and take a look at your webpage and see which practice problems I would like you to work on. Practice problems should be starting on page 421 in your book.